Electricity and plumbing students, Mr. Voigt here. We are going to go over the diagram for your Lab 2A. As you can see, let me go ahead and point some things out here. We're going to have one circuit, which means one circuit breaker, two duplex receptacles, and one light. If you look at Lab 2, the lab right before this, we had one circuit, two duplex receptacles. So what that means is all we did really is add a light up here. Okay? And all of this down here is going to work the same. The only thing is we have a light. So feed through the switch box just like before. Here's our feed into our switch box. Top receptacle is switched down here just like before. Bottom receptacles are continuously hot. And our light, and this is maybe the most important thing, has to be switched. You don't want to feed this hot. What happens a lot, one of the biggest mistakes is people make this light continuously fed with electricity. In most lights, you want to turn on and off, right? You don't want them on all the time. So remember, our feed is a 14-2 cable. Could be a 12-2 cable. 12 and 14 are the size of the wire, 12 being bigger than 14. And then we have a white wire in there, which is our neutral. That is a grounded current carrying conductor. We have a black wire in there, a wire with black insulation on it. That is our ungrounded current carrying conductor that feeds our circuit, and then we have a ground wire in there. This wire has four wires. It has a white, a black, a red, and a ground. The red is an ungrounded current carrying conductor, just like the black. This one obviously is 14-2, and down here again is 14-3. The number comes from the number of insulated conductors, current carrying conductors, in other words. Okay, so we need to feed this switch with electricity, and we need to continuously, and we need to feed our bottom outlets down here continuously. We need to feed this light with switched electricity, and we need to feed our top receptacles down here with switched electricity. So our top receptacles and our light will come off of our switch. That's why they're switched. Our switch needs electricity to allow through when you want it to and not allow through when you don't. And our bottom ones have to have electricity all the time. So we start drawing with our black. Okay? We need to get, we're going to pick one of these wires. We're going to choose this one to be our black one. One of them on here, we'll choose this one to be our black one. So what we've done now is taken our hot electricity and fed it down to here, right? We also want to come off and we want to feed our switch. It doesn't matter on a single pole switch which one of these terminals gets fed. But it will matter on other switches, but not a single pole switch. So now we have hot electricity down to here. Okay? We need to get that. Oh, by the way, we should have a tab right here because we didn't want to pull that tab. Notice that the tabs are gone on the hot side, just like the last lab. Anyway, we bring our black down to here. Remember, this is hot all the time. We're going to feed our bottom outlet right there. Then over here, we're going to go ahead and just feed our bottom outlet. So we got everything fed with hot electricity, continuous hot electricity that needs to. Our switch, our two bottom outlets. Okay? So now we're going to go ahead and do our switched side. All right? Our switch side, so when this goes on, electricity will come out and it will feed. I'm going to go ahead and grab, how do I want to do this? Okay, so these are the two things that will get fed when our switch is on. And then we put a pigtail. So when the switch goes on, it's already fed. So this is hot all the time. Switch goes on, it lets electricity go out through this red wire, and it feeds it that way, and it feeds it this way. Right? Up here, we're going to go ahead and take our hot and hook it to our hot terminal. Down here, okay, we're going to assume that this is our hot feed from our switch. When it's on, you want it to feed over to here, and then this will hook right to that. We then have to take a pigtail to our hot side there. So now our hot electricity is everywhere it needs to be. Okay? So we got electricity going to everything. when the switch is on. When the switch is off, obviously electricity doesn't go to the light, and electricity doesn't go to these upper outlets. But we have it hooked up. So what needs return? A light switch is not powering anything. It's just allowing electricity to flow through it. There's no power being used here, per se. Down here, when you plug something in, whatever you plug in will use electricity. When that light burns, it will use electricity. Any place where you're using amperage, you need to have return electricity. So we don't need return electricity to a switch. We've been over this. I'm just reviewing it. But we do need return electricity to our light and both of our outlets. But remember, we have tabs down here, so we only have to hook one neutral to these outlets, and anything that goes through it will have a return path. So up here, this is our neutral. And we're going to go ahead and just put it out here. We have to have a neutral going down to our outlets, right? And we have to have a neutral going up to our light. So we're just going to go... Notice it does not go to the switch. You don't need your switch hooked to a neutral. Now, nowadays, there are exceptions to that, but if you have electronic switches that are run off the internet, or you have timers in them, or any kind of little lights, then they will need return because they are using electricity then. Because in order to have Wi-Fi, it has to receive a signal, and it has to have an electrical circuit. So a lot of new switches might need this, but the ones we're using are all mechanical. They're all old school. Okay, so we have it down to here. We're going to come over here. We're going to come right there. And we need to hook to here, right? So I'm just going to go right to it. Doesn't matter which one of those we hook to because we have that tab. And then over here, we're going to take this and we're going to hook to one of those because we have a tab. It doesn't matter which one we hook to. So now, this circuit will work. It'll work. You don't need the grounds to make the circuit work. In fact, a lot of old well, I forgot one. I'm sorry. Up here, we have to hook this to our light. Now our whole entire circuit will work. I forgot to go up there. Okay, so now, grounds. I'm going to go ahead and we do the same thing here. We do hook our, so I'm going to come over here and over here. I'm going to put my pigtail into my ground there. Before I forget, I'm going to come up here. I'm going to hook that to my ground. Down here, just like on any other circuit, hook our grounds together, come off here with a pigtail. And then over here, we're just going to come all the way around to our ground. So, I went through the grounds pretty fast, but that's the same thing as we did on our circuit before. The only thing we have to do on this circuit, all this is the same, right? All of our grounds are the same, except for we had to add this so that we had that up there. The big thing is this hot red wire right here. Okay, and actually, I probably shouldn't have drawn it red. I probably should have drawn this black because it's going to be a black wire. That black wire hooks in with those two red wires in your 14-3 wires. And this only gets energized when that switch is on and lets electricity through there. So that is lab 2A. That's an important one. This is one you have to take a test on at the end, so try to remember this.